All right, so the next thing to learn about is something called the first derivative test. Back in 4.1, we learned about critical numbers and said, okay, these are numbers that are candidates for local maximums and local minimums. And at the time, we didn't really bother figuring out whether or not they're maximums or minimums. We did use the closed interval method where we found the absolute max and the absolute min on a closed interval. But for each and every one of those critical numbers, we still did not figure out if there's a max or a min there, or neither, because you could have neither. So here is a test that you can perform to determine, given a critical number of a continuous function, if you have a critical number, we're going to call it C. This is a test you can use to determine if you have a local minimum or local maximum or neither. And this is a fully conclusive test. You will find out for certain after doing this test what's going on. So there's three parts. We have a continuous function f, and c is a critical number of f. And then first one, if you have for f prime in your sign chart at c, if it changes from negative to positive, okay, if there's a change from negative to positive at c, then what that means is that f has a local minimum at x equals c. And if you want to figure out what the actual minimum value is, then you can evaluate the function at c and get the y-coordinate of that point. But we're talking about just identifying whether or not there's a min or a max at that critical number. So if it changes, if f prime changes negative to positive, then there's a minimum. And the reason for that is because you have something where it's decreasing and then increasing. And you can see if it goes down and then up again, there must be a min here. There must be a minimum right there, right? Down and then up. So the second thing is if we flip it around. If on our sign chart, for f prime, it changes from positive on one side to negative on the other side, then that means f has a local maximum at x equals c. Because it's positive on the left means increasing, negative on the right means decreasing, so at this point here it must be a max. Okay? So this is all about just checking to see if you go up and then down or down and then up, right? That's pretty straightforward. And then the third case is anything else, right? So if you have positive and then still positive, okay, so if it doesn't change sign, or if at c it goes negative and then negative, like that, okay, if it goes positive to positive or negative to negative, so it doesn't change sign, then that means f has no local extreme at x equals c. So that would be something like it's going up, and then maybe it levels off and then keeps on going up. Or maybe it's coming down and it levels off and then it keeps on going down. So there's some kind of a critical number, but it's not actually a min or a max, right? So so there we go. So that is a test you can use to determine that information. So now going back to the example, we had f of x was equal to e to the x times x squared minus 3. That was the function we were dealing with. And we found f prime and did a sign chart for f prime. F prime had two critical numbers, negative 3 and positive 1, and we discovered that the sign went from positive to negative and then back to positive again on those intervals. So then we can conclude at x equals negative 3, since it changes positive to negative, that is a increase and then decrease. That's case 2, positive to negative. We must have a local maximum. At x equals negative 3, f, this original function has a local max. And then at x equals 1, since it's changing negative to positive, f has a local min. So that's how you take that sign chart information, okay, about increasing and decreasing, and then use that to make a conclusion about where your local minimums and local maximums are. In this case had two critical numbers, but there's lots of examples where you can pick. There are examples where you've got any number of critical numbers, from no critical numbers to just like 5 or 6 or however many you want. You can have functions with an infinite number of critical numbers and an infinite number of local minimums and maximums. I'll bet if you look at our basic functions that we work with all the time, if you think about those, I bet you could think of an example of such a function pretty quickly. So, I'm curious to hear if you figure out what that is. A function with an infinite number of critical numbers and an infinite number of local minimums and an infinite number of local maximums.